Okay, let's look at verification now. I made modifications to RTO2. We'll come back to those. Program 01, which is RTO1.c, is the program that I wrote in C to solve the same scenario. Does the scalar invariant embedding. It will handle up to order 15 on the Gauss-Legendre quadratures. And I forget when I wrote this, but it's been fairly recent. Just wanted to, one, redo the code because the Fortran, if you remember, is my first one I ever wrote, and it wasn't pretty. So let's go and make this thing. So that goes and compiles RTO1.c and moves the binary, the executable, to bin, so it's RTO1. And I have a script set up to run some stuff, run.sh, and I can do tals of, well, I did 0.0625 up to 5, so I want to compare the maximum tal here. It's just as good a case as any, so let's just run that. Could run the whole script, but let's not waste time. Let me copy that, Control-Shift-C, Control-Shift-V, puts it back, so let's run it. Oh, let's time it too. Time, and let's run it. Oh man, 0.2 seconds. My output is in 006.out, so if I VI 006.out, and that's my output, and it's a bunch of numbers. So I'm interested in just looking at the values, not the comment section. So this is line 6 through 20. So I'll just extract those. Sed minus n, I don't want to look at anything else. 6 through 20, print 006.out, and let's put that into a file. And since this is program 1, I'll do an 01 dot, it's run 006 out. And let's look at it, make sure I got it correct. 15 lines and lots of beautiful numbers. Now I'm going to generate the same case with RTO2, and it's in O2 backup, so let's copy the results here, 01.006.out to O2/backup. Let's go to O2 backup, clear the screen, do an ls, and let me remove RTO2 because I'm going to compile it. I told you that I would go and add the weights. I had to go and add the weights for a 15-point quadrature. This looks pretty ugly, but I used Mathematica to generate them to 25 places. Now in C, double precision arithmetic is only good to 16 places, but it's better to have too many than too few, I think. And it looks pretty ugly, but there's the zeros and there's the weight. And I got 30 lines of 15 values. One other thing that happened when I went through the procedure to convert the 9s to 15s, some of the lines exceeded past column 72, and G-Fortran flagged them, and I came back and cleaned them up. There is an option, but there's no man page for G-Fortran on the orange pie. So if I do a man on G Fortran, no entry. If I do an info on G Fortran, there's no entry. So I'd have to go to the web, and I'll just fix the program. It's faster to fix the program than to do anything else. Also, I had to change a format statement to get 15 values per line. So let's compile this thing. G Fortran minus F no automatic. I shouldn't have a make file, but I'm just too lazy, huh? So now I have got the output. Let's see if I've got my data input is correct. Order 15, tall 5. All right, so let's execute RTO2, input the data, and let's do the output to 001.out. Whoops, got a floating point exception. I'll show you why I got that. Now if I vi 001.out, there's my output. So let's go, we want lines 7 through 21. Sed minus n, 7, 21, print 001.out. Now this is the results from 02, and it's to rerun the cases 006 from my RTO1.c, so I'll just make this 006.out. vi 002, excuse me, 02.006.out, and it looks good. Now I said I was going to plot these, but I don't have to. I can just do an mgdiff between 01.006.out. I'm going to call that my standard. Then for the modified RTO2, its output was 006.out. And we can see that they look almost alike, except I've got one line here that has a number that's different. So let's see if we can determine what it is. It's 450807. This is 189 for the last 3 digits. 189, 237, 237, 672. You following along? 672 on the right hand. 525, 526. So this number right here in this column is one off in the 7th place. Now let's check the rest of them. Where was that? 26? Did I get the right number? 1, 2, 3, 525, 526. Okay. 356, 356. 4827, 4827. 538, 538, 030, 030, 754, 754, 775, 775, 016. So go down here and slide right. Okay. 810, 810, 483, 483, 2911, 2911, and 596, 596. So of all these 225 values here, there's only one number, and it differs by one place. And that's just, we'd have to do some complex numerical analysis. Actually, we don't. The two programs are not the same. And the difference is the following. When I did RTO2 in 1966, I had to remember there were no computer science departments or anything, so I had to do everything. And what I decided to do was I used the Runge-Kutta technique to start off the integration of the differential equations. And then I shifted to an modified Adams-Moulton-Bashforth integration routine. Forgot the other mathematician. So there's two integration schemes here. In RTO1.c, there's only one integration scheme, and that's the Runge-Kutta. Now both schemes have an error of O to the fourth, where O is going to be related to my step size. So there's a chance that possibly if I make H even smaller, maybe they'll come out exact. I don't want to waste your time. That's an exercise for another time. But I'm satisfied that RTO1.c, which is my preferred program now because it's written in C, we could benchmark these on the time, but I'm not going to worry about that. Now, where did I get O? When I ran RTO2 with 001 and output that 01 dot out, where did I get the error? Where did I get the warning? Oh, I did? Look at that. I ran it again and it didn't get the underflow. I didn't change anything. You just saw me do it. All right. Well, let's see if there's a let's just do the task set. Let's time it. Let's task set 0x01. That's RTO2 001 dot out. Now this will run it on the slower one. Okay, it took 4 seconds. Let's do time task set 0x10. Let's run it on CPU 4. Try it again, and it took 0.7. That's what is that? That's much faster than I would expect. Let's do a quick, and this is just gonna, let's do this, sudo lshw pipe to more. Now there was a thing here that on these systems, the level 1 cache, the fastest thing in the system is the registers. The level 1 cache is memory that's faster than the solid state, or the DDR memory, and slower than the registers. There's 32K in these first 4 processors, and then on the 2.4, they've got twice the cache. And the slowdown may be the fact that I've got more cache for the faster processors. That's always the game that the CPU architects have to worry about, is how the cache is. Let's see, do we have a level? I don't think we have a level 2 cache. Watch this. I'm gonna bang sudo, and then I'm gonna grep for L1. Okay, bang su. Let's grep for L2. No L2 cache. So there's only one level of cache. So evidently, the cache is affecting the time. That's my guess right now. And there do exist benchmarks to test that. So let's save that for a later exercise. So I just wanted to show you that I was able to get R202 to run with the increased quadrature capability to 15, and a code that was written in 66, which makes that, 57 years old, gets the correct results from code written in 2023. Now you could say, well, it's written by the same person, but okay, but it's the same set of equations. The RTO1.c I wrote from scratch, just using Chandrasekhar's book, and evidently I understand the math. And I have another way to check it, and we'll do that. So how am I doing on time here? I'm up to 17 minutes. Was there anything else that I could show you? Since I got you back for another round here, 17 minutes. Let's see. Oh, yes, now, why did the error go away? Let me look at 001.out. Did I? Oh, what's this? Oh, I'm in the wrong, excuse me. I need to go back up. Oh, let's try it. I was running the wrong code. Okay, this is a warning. Okay, now I mentioned earlier that there are 3 standard devices already assigned. Device 0 is the input from terminal. Device 1 is the output, standard out, and then 2 is error and warnings out. Now, I'm not worried about this warning, am I? So let's run it again. Now we'll do standard out to there, and then I'm going to reroute the errors to /dev/null. Or if you want to, I can do warning.out. Now I don't see the error, I don't see the warning. So let me vi warn.out, and there's my warning message. So previously you saw me use, do I have a PDF? Let's see here. Oh, do I have a PDF? Yes, I do. I have Kernan and Ritchie. When I do events on the C programming language, I get this warning. There's the book, but I get this warning. Let's get rid of it. I consider a programming bug in events. Just doesn't work correctly on every system, so let me get rid of it. And the way I can do that is I can go to my home directory and VI the startup script, startup run command for bash every time I open a window. or start up another bash invocation, this script gets run. And somewhere in here is an alias. Okay, there's an LL, an LA, and an L, which is to run ls with these flags. We'll come back to them. So let me do another alias here. I'll do an alias. All right, events equal, quote, events with output of any warnings or errors to /dev/null. Now this, of course, is dangerous in that if something really goes terribly wrong, I won't see it. I'll have to do it without that alias. So, all right. Now, since I changed this, I need to either start a new window or I can do a source .bash rc, which says just read this in and do everything it tells me to do. Let's see, there's a thing to do alias. Alias shows me all the aliases in effect, and there you see it. One of the last alias is ls is really ls with a curly with color equal auto. That's how you get blue for directories and green for executables and white for plain text. Let me do an LA. That lists the hidden files, the ones that start with dot, and hidden directories. What is L? That shows you the directories with a slash after them. I think executables, let's see. If I do an L, oh, I don't have an executable. Yeah, executables are shown with a splat after them, an asterisk. Okay, so now let's go back to O2. Where was K and R? Oh, cdk.and_r. Now if I do an events on the C programming language, the book comes up, I can read it and everything, and I don't get the nasty grams showing that there's a problem. I don't get the warning. I've rambled on. Apologize, but I wanted to show you that continuation of programming, that I was able to verify that my program RTO1 and RTO2 both agree with each other. So all is well in the land of Oz. Thank you, and I'll be back with another lesson soon.